This question is from GATE 2022 Mechanical Engineering paper set 1, question number 40. A bracket is attached to a vertical column by means of two identical rivets U and V separated by a distance of 2a of 100 mm as shown in the figure. The permissible shear stress of the rivet material is 50 megapascal if a load P is 10 kilonewton applied at an eccentricity E 3 root 7 times A. The minimum cross-sectional area of each of the rivets to avoid failure is dash millimeter square. Let's find out. Now on each of the rivets, let's consider one of these rivets which is U. So on this rivet there will be two forces. One is the direct shear, for which direction will be same as the direction of this force P, that is vertically downwards, and magnitude will be equally distributed among the two rivets. So because there are two rivets, magnitude of direct force on each of the rivets will be P by 2. We can write direct shear on each rivet, let's denote it by Fd, is equal to P by 2. Now because this force P is an eccentricity E from the rivets, it is going to create a torque on the rivet, and that torque also has to be distributed among the two rivets. So in order to counteract this torque P into E, which will be acting at the center of gravity of this joint or this connection, so center of gravity is going to be at a distance A from each of the rivets, and P into E will be the torque acting at this center of gravity. Now this torque has to be distributed between the two rivets. So how will that be done? Let's consider the secondary shear force Fs being acting on each of the rivets in this way. So this torque will be equal to, we can write down secondary shear force on each rivet. That be Fs. In order to find this, we'll equate these two torques. So Fs into 2a will be equal to P into E. Rearranging this, we have Fs will be equal to P into eccentricity is given to be 3 root 7 times A divided by 2A. So this is nothing but 3 by 2 into root 7 times P. We have each of the forces here. Fs is going to act in the horizontal direction on the rivet. So to calculate the resultant force on each rivet, we have resultant force, let it be R, on each rivet. Now this standard formula you must know. It is under root of square of the direct shear force Fd square plus square of the secondary shear force Fs square plus 2 times Fd into Fs into cos theta. This is a standard formula for finding out resultant of two forces acting at an angle theta to each other. Theta here is 90 degree because we can see that angle between these two forces is 90. So substituting theta as 90 degree, we will have this will be equal to under root of Fd is nothing but P by 2 whole square plus Fs is nothing but 3 by 2 root 7 times P whole square. So cos 90 is 0 and therefore this complete term becomes 0. Here we will get R will be equal to under root of P square by 2 square is 4. So we have this as P square by 4 plus this one here is 3 square which is 9 into root 7 square which is 7. So in the numerator we will have the coefficient of P as 9 into 7, 63 P square divided by, in the denominator we'll have 2 square as 4. So carrying out the addition and taking P square out from the square root, we will have P times under root. This here is 64, 63 plus 1, 64 by 4, that is 16. So this is root 16 which is 4 into P is given to us as 10 kilonewton. So we can substitute it here. 10 into 4 becomes 40 kilonewton. So we have our resultant force with us. This is resultant shear force on the rivet. And using this we can find out the cross-sectional area. Let's find that out. So we are being given that strength of material used for making the rivet, that is tau s, is given to be 50 megapascal. For the design to be safe, we should have tau s should be greater than or equal to tau. Tau is nothing but the shear stress on the rivet. That means 50 should be greater than or equal to resultant force R upon the shear area AS. So this shear area AS should be greater than or equal to R by 50. Now because AS should be greater than or equal to R by 50, we know that minimum value of this AS shear area will be nothing but equal to R by 50. that is the limiting value, limiting minimum value. So this will be equal to R is 40 kilonewton. Let's convert it to Newton. 40 into 10 to the power 3 Newton divided by 50. We did this because 50 is given in the terms of megapascal, which is equivalent to Newton per millimeter square. So in order to find the area in millimeter square, we have converted the force to Newton. This we get as 800 and it will be in the unit millimeter square. We found out minimum shear area, which is 800 millimeter square for the rivet. Let's go back and mark this option. So our answer is given in option A. 800 millimeter square is the minimum cross-sectional area of each of the rivets to avoid failure, because we did consider the safety for design. To learn more about such eccentric connections, you can refer to the NPTEL video, Module 3, Lecture 5, Eccentric Connection. It is from the course lecture series on design of steel structures. The course is taught by Dr. Damodar Mehti. He is from Department of Civil Engineering of IIT Guwahati. I hope this solution helps you clear your doubt. Thank you.